Okay, so the first thing that we are going to take a look at is the background information because we need that in order to make our graphs correctly. So it says that you're part of a biological research team and you notice that the labels on your collection bottles have fallen off. But you do remember that you collected 3 different digestive enzymes, and you know that one of the enzymes comes from a bacteria that lives right in the middle of an alkaline hot spring. So in our vocabulary words, we are going to go over what alkaline means. So that we can figure out, okay, what kind of conditions should the bacteria enzymes be able to survive in? And then the other 2 enzymes are going to have come from the digestive tract of a mammal called a Mondani. And that animal lives at the edge of the spring. So I'm also going to talk about, well, what kind of conditions should the enzymes from this Mondani mammal be able to survive in then? The next thing is going to be looking at vocabulary so that we can determine which enzyme goes with which. So first thing you need to do is fill in our vocabulary if you didn't do it from the homework last night. We're looking at enzymes, and enzymes are proteins that speed up chemical reaction. Proteins are needed to do lots of different things in your body. So these enzymes, they may come from an alkaline location. Now, if you remember, the bacteria is going to be living in an alkaline condition. So we have one of the enzymes where we're going to be looking to see, does the enzyme function the best at pHs over 7? So if it is going to function very well at a pH over 7, then that means that that enzyme comes from the bacteria. If it's not functioning well at pHs over 7, then that means it must be one of the enzymes from the mammal. Bacteria are single-celled organisms, and we're trying to figure out which enzyme comes from the single-celled organism. We also want to find out 2 of them are going to come from the digestive tract of a mammal. So those are simply the organs in an organism that break down their food into smaller compounds. pH, if we have a pH that's less than 7, then that means that hydrogen ions are being released. You'll learn more about that in chemistry next year. We're looking for pH greater than 7, and we're looking for the enzymes to function the best in those kinds of pHs. And that means that that must be our enzyme that came from the bacteria. Now, we also want to remember that the bacteria are in a hot spring. So that means that we're also going to want to look and find out which enzyme works best in high temperatures. And so if it works best at a high temperature, then it must be from the bacteria as well. So we're looking to find one that is going to work really well at a very high pH, and we're looking to see what enzyme works best at higher temperatures. The other 2 enzymes then will be from the All right, so I'm going to go through all of the different variables, and then you are going to be making graphs from the data table. So you're going to use the graph paper and the data table in order to make the graphs for each of the enzymes. I will go over with you in this video how to write a proper title. You're going to put all 3 enzymes on the same graph. You're going to use a different color for each of the enzymes, and you're going to need to include a key. I'll also show you a little bit about that. Total, you're going to have 2 graphs for each enzyme. I'll show you that as well. We actually want to make sure that we are using straight lines connecting the points. So we don't want to have curvy lines or anything like that. And when you're finished, you can work on answering the questions in the analysis. If you don't finish the graphs in class, then finishing the graphs is homework for tonight. Okay, so the first thing, what is the problem in this activity? The problem is that we need to determine which enzyme comes from which animal. So that's our first problem. So determine which enzyme comes from which organism. So we've got 3 enzymes, and we need to determine which one comes from the bacteria and which 2 come from the mammal. So we're going to create a hypothesis as how we can determine the source of each enzyme. So we want to remember that the bacteria are living in the hot spring. So that means that they're going to live in very high temperatures. And remember that this hot spring is alkaline. And alkaline means that there is a high pH, over 7. If it comes from the mammal, which lives on the edge, the mammal is going to have lower temperatures and lower pH. And we're going to have 2 of our enzymes that come from the mammal and 1 that comes from the bacteria. So for our hypothesis, remember a hypothesis is going to be a prediction. So how are we going to figure this out? So if an enzyme functions well, and if we look at our data, we can kind of see we're looking at the enzyme activity. So a high percentage of enzyme activity means that it is functioning good. So 100% would be like it's functioning really well. 0% means that it's not functioning well. So when we look at our hypothesis, if an enzyme functions well at high temperatures and a high pH, then that enzyme is from the bacteria. Then we need a because bacteria live in high temperatures and a high pH. So notice how my hypothesis has an if, then, and a because. Now the independent variable, that is what the scientist is changing. So what we're looking at here is we're looking at the different temperatures and we're looking at the different pHs. So, and notice independent variables will normally have pretty regular intervals. So if we actually look down here at our data, you'll notice how the percent activity, which is given here, here, and here, you'll notice that the percent activity is not always an equal amount, whereas the pH always goes up by 1. So that's an indication to us that that is our independent variable. The other thing that we're going to look at on the next data table down here is that temperature. So again, we've got the equal intervals. So again, that is going to be our independent variable. So coming back up here, what is the dependent variable? What's being measured and determined by natural law? So what we're looking at is we're looking at the percentage of the enzyme's activity. So basically we're looking at, well, how well does it function? Finally, we want to look at the data and we want to see, this is going to help us with our graph. What's the lowest pH and the highest pH? So it looks like our lowest pH is 1 and our highest pH is 14. It looks like our highest temperature, if we go down to the second data table, our highest temperature is 0 degrees Celsius. I'm sorry, our lowest temperature is 0 degrees Celsius and our highest temperature is going to be 100 degrees Celsius. And then the maximum activity of the enzyme is 100%. And the least amount of activity we see is 0%. So that's going to mean if it's 0%, that means it's not functioning. So what you're going to be working on is making the graphs. So I'm going to work through a little bit with you. First one we're going to do is pH versus enzyme activity percentage. So we're going to write a title for our graph. We want to make sure that the graph includes both variables. So we want to include pH and enzyme percentage activity in our title of it. We're going to include both of these in our title. So our title of our first graph is going to be enzyme percent activity at different pHs. That's what that data is showing us. It's showing us the percentage of activity at different pHs. Now, we need to go from 1 to 14. Our independent variable always goes down on the x-axis. So we're going to put the pH down here. We need to go from a pH of 1 all the way to a pH of 14. So what I'm going to do is I'm going to count how many spaces I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. And you know what? That's pretty good. 28 times 2, or 14 times 2 is 28. So basically, I think because I'm almost to the end here, what I'm going to do is every 2 spaces, I'm going to put a pH, and that's going to help me use the majority of my graph. So I'm going to go ahead. I'm going to start with a pH of 0, and then every 2 spaces, I'm going to put a number. And so you should do your graph the same way, because that way we're making sure that we are using the majority of the graph by spreading them out this way. And then we're going to do something similar in order to determine what's our scale going to look like on the y-axis. So again, we're going to start at 0 because that is our lowest percentage activity. We're going to label the y-axis as percent activity. And then we're going to count how many spaces we have because we need to go from 0 all the way up to 100. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42. So that's unfortunate because if I did 100 divided by 50, if I had 50, it would be a nice easy divider. But I've got 42, and 100 divided by 40 is not a very nice, easy number. But I'm thinking that instead of going up by 3s, because 100 divided by, you want to think about these things, 100 divided by something like 40 is going to be going up by an uneven number. So if we do something like, how do we get 2.5? Like think about quarters, okay? If I were to go up by 2.5, I would go every 2 spaces would be 5. So if you think about, we've got 40 spaces, and if for every 2 spaces is 5, then we should be able to get up to 100 pretty easily. Okay, so take a minute, and every 2 spaces, you're going to put another 5. So every 2 spaces, I'm going up 5, 10, 15, nothing, and then 25, mark a space, and then 30. Mark a space, and then 35. You don't have to label every single one, because otherwise then we'd be going 2.5 and 7.5. It's just easier to skip a line and then 5. So 2.5, 5 puts us at 45. 2.5, 5 puts us as 50. And so you're going to work your way all the way up. Every other line marking it as a percentage activity of 5. Now the nice thing is the other graph, we also need to do percentage activity on this same axis, and the graph is the same size. So that means that we know the other graph is going to have the same scale on this side here. And we've already figured out how to do that scale. So notice how we use most of our graph and we're going all the way to the top. So since that y-axis is going to be the same on both of the graphs, let's go ahead and do the other graph as well. The other graph we're doing is on temperature. So again, we have to go all the way from a percentage of activity all the way from 0 to 100 because that's what we've got for both of them. So we're going to go down to this next one. Our dependent variable, our data, is always going to go on the y-axis. So we're going to label it as percentage of activity. We already know the lowest percentage of activity is going to be 0. And every other line we're going to label as another 5% until we get all the way up to 100. And then we'll have both of our y-axes ready to go for our graphing. So I'm just working my way up. My y-axis is the same for both of them because we're collecting the same data when we look at pH and the same data when we look at temperature. So that's why our y-axis for both of these graphs is going to be the same. Okay, so go ahead, take a second, finish up until you get all the way up to 100. Hopefully I didn't miss a number here. So be careful that each 2 you're going up by 100 or by 5. Okay? Now, we now have a graph with our x and y axis ready for our pH. So we're going to take enzyme A and we're going to graph that data for each pH in the graph right here. Now you're going to need to do a different color for each enzyme. So you can pick the colors, but I'm going to use green for enzyme A. So we're going to need to put a key on our graph as well. You're going to have 3 lines on your graph. So I'm going to do enzyme A green. That's going to be my first line I'm going to work on. I'm going to do enzyme B blue. That's going to be the next line I work on. And then I'm going to do enzyme C in pink. And that'll be the next line that I work on. So I'm just going to do one data point with you. So I want to point out that pH of 1 for enzyme A was 0. So I'm going to go down here. I'm going to make sure I'm on green. I'm going to do everything for enzyme A. So, got to make sure, there we go, that I'm in green. So I'm going to have 0 for my pH, 0 activity. Then I'm going to go up and I see at a pH of 1 is 0. So at pH of 1, I'm going to go 0. Then I'm going to go up. pH of 2 is 100%. So that means that I got to go up to my 2 and up to my 100. And I'm going to put a dot right here. And then if you hold the line, it'll automatically make a straight line for you if you hold it in the space. And so you're gonna plot all of the data for A in green. Then you're gonna do all of the data for enzyme B in another color, and then you're gonna do all of C in another color. Then you're gonna do the same thing with this other graph. This other graph, we're gonna put temperature on the bottom axis. And we have to go all the way from 0 to 100. Well, this bottom axis down here is, looks like it might be a little bit shorter than the other one. So let's take a look and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Oh boy, so 30, that's unfortunate. Going up by 3s is a real pain in the butt, especially because our temperature goes up by 5s. So, okay, so we have to get up to 100, and we have around 30-ish lines or so. That would mean that we've got to go up by 3s. But going up by 3s, going 3, 6, 9 is really kind of hard. So instead what we're going to do is we're going to go every 3 lines, we're going to have be 10. So that means that like right in the middle here, that would be 5. So we're going to go 1, 2, 3, 20. 1, 2, 3, 30. 1, 2, 3, 40. 1, 2, 3, 50. 1, 2, 3, 60. 1, 2, 3, line 70. 1, 2, 3, 80. 1, 2, 3, 90. 1, 2, 3, 100. Now, since our data table up here has us go every 5 degrees, we're going to go back and we're just going to make in between, we're going to label where our 5s would be. So our 5 spaces, you can kind of see, I'm going to zoom in a little bit here so you can see what I'm doing. In between these 2 spots, for every single spot, that's where your 5 is going to be. So 5, 10, 15, 20, 25. So we've got 30, and then we got a space, and then right in the middle here, that's where we're going to have 35. Because basically each of these lines is like 3.3. So we got 40, we got a line, we're going to go right in between those, and we're going to mark it as 45. Okay, and the reason that I'm doing that is because I have to put in those datas. So I need myself marked so that I know, well, where is 65 degrees? Where is 75 degrees? Where is 85 degrees? Where is 95 degrees? So I got it in different colors here so that you can kind of see it a little bit better. But basically, since we go, since we go 30 and then we go 1, 2, 3 lines and then we go to 40, that means that in between these lines of each set of 10 is where that in between number of 35 is going to be, or where that in between of 45 is going to be. Okay, so unfortunately it's not a very fun scale to do, but now you've got both of your scales done. We do need a title for this graph. This second one, we are looking at temperature versus enzyme activity. So we're going to call this enzyme activity at different temperatures. So we're going to call this guy enzyme activity percent at different temperatures. Both variables, enzyme activity and then the temperatures that we're going to use. So again, this one is also going to have 3 lines because notice here we've got enzyme A, enzyme B, and enzyme C. So just like we made up here, we made this key. I'm going to go ahead and I'm going to circle my key, and then I'm going to copy it, and then I'm going to come down here. I'm going to use the same colors, and I'm going to go ahead and paste my key right down here. And so if you want to know how to do that, you use the button, that's that like circle guy over here. So you tap on that, and then you select your item, you circle around it like I did here, circle around it. Oh, nope, I got my eraser on. Hold on, go back. There we go, got my circle on. I'm gonna circle around it, and then I tap it, and then I hit copy, and then I scroll down, and then I tap, and I hit paste image. Okay, so you've got the rest of the class period now to work on making your 2 graphs. Any work you don't finish of making these 2 graphs is homework for tonight. You should have both graphs ready and done for